You're in the right place. My promise today, this is not a sales pitch. There'll be a tiny little brief mention of my company at the very, very end. But my goal is to help you understand, if you're embarking on this journey of using feature flags, that having the data align with a feature flag and actually being able to use it, not just to limit the blast radius, but, well, I'm getting ahead of myself. Let's just jump in. And for some of you, so I am a continuous alert evangelist at Split, but for some of you, feature flags may be new, or you're just learning a little bit about them. Some of you have been using them for a while. We'll do a quick review of feature flags at the beginning to make sure we're kind of all on the same page. And then we'll get into the kind of the meat of it, which is the data. So how you measure matters, and you really shouldn't believe everything you see. And then flags and data together, really, when you think about it, is an experimentation platform. And it's helpful to know what makes those things work well. So let's do the recap on feature flags, right? These are a tool to decouple deployment from release. And if you haven't been in that world yet, if you haven't actually been in a world where deploying isn't what takes things live, it's a huge difference, right? It's much less stress, much more control. You put code out there whenever you need to, and you release it to users when you're ready, right? And the way we do this is with feature flags, are really just a conditional statement, an if-else statement that can be remotely controlled, separate from a code deploy. So you make your deploy, and you then separately can control who gets access to the releases or to the pieces that are in that code, right? So flags can come in several types. It might be a simple on-off switch. I want this feature to be out there or not. I might be doing a ramp, and this is a more typical case where I want to gradually expose my code to a population. And then there might be a multivariate or multiple solutions where you're trying. One example I like to bring up is you may have a legacy search engine, and you may be trying out 2 new search engines on the back, and you want to actually divvy that up to different populations and see how each of them sort of respond to the different treatments, right? So let's talk about the phases of rollout. And this is where those of you who are already using feature flags, some of this is going to be very familiar to you. And some of this you might say, well, gee, we hadn't really thought about this step. So first of all, deploying code doesn't expose the code to the user. If a feature flag is turned off by default, which is a best practice, the deployment doesn't change anything. And if it does, you've got a problem with your deployment. But once we get that deploy out there, then we're going to want to do a partial ramp to users. And really, we're going to start with the developers and the testers. So this lets you test in production and actually use the production infrastructure to confirm that everything works as well as you thought it did when you were testing pre-production. And then you go from there to maybe dog fooding, having your own employees be able to use the feature, right? And then from there, we're going to ramp up to maybe a very small population. And our goal in all of that is what I would call error mitigation. We're trying to make sure that if we've missed something, that has the least impact possible. And you'll hear this term called limiting the blast radius, right? So we want to actually, if there is something we missed, and invariably now and then we're going to miss something, we want to catch it before we roll it out to everybody, right? And then when you've gotten past the error mitigation, you feel pretty confident about your code, you go to a stage that we would call measure, which is if you want to be able to understand whether this feature really moves the needle, does it accomplish what you set out to accomplish when you built it? You need a lot of data, and the more data, the better. And that's something called maximum power ramp, which is you want to put as many users through both sides of the experience, the on and the off, or the different flavors. And essentially that's splitting in 50-50 if there's only two treatments, right? And your goal there is to understand the impact, system level impact, business level impact. You want to understand, is the code doing what you set out to do, right? And then we're going to continue the ramp. And you'll notice there's this scale mitigation step. And we might not want to go as soon as we, oh yeah, this feature works great, let's get it to everybody. We may want to actually push it to 60 or 70 or 80% and hold it there through a peak traffic period. So it's a safer bet to actually hold out a little bit of population, go through peak traffic period to make sure you don't have any issues with scale, right? And then we're going to release, we're going to roll it out to everybody. And we're kind of done with the rollout at that point. Now, this is the meat of the talk, which is, okay, great. We're rolling it out to see if there were any errors. We're rolling it out to sort of limit the blast radius. We're rolling it out to figure out whether it's doing a good job. Well, how you measure matters. And when you're moving to this different world of using gradual rollouts, you have to kind of change your thinking a little bit, because traditional charts and graphs and thresholds really aren't going to serve you. If you're, for instance, giving exposure to just 5% of your population, then things aren't going to show up the same in the graphs as they would when you're doing kind of a big bang release, right? So This is a screenshot from our own Datadog a while back. We were in the middle of doing a new release, and we started rolling some stuff out, and then this happened, and the charts were going crazy, right? And you might think, oh, well, we were doing a release, and then this happened, so it's got to be the release. We'll learn in a minute that wasn't the case. Let's look at a little more common situation. So we learned a while back that it was really helpful to overlay feature flag changes onto our graphs, right? And you can see here what you kind of expect, which is that the feature was enabled 100% and something went wrong. There was a step function where something went way up, and that's probably latency, and something went way down, and that's probably throughput, right? Now you say, well, see, that's easy to see. I don't think we need to get sophisticated about this. It's obvious, right? Well, the problem is that that other line there is when we took the feature to 5%. So think about that. We took the feature out to 5% of the actual users because we wanted to see how it was going to go. And we didn't see any change over the sort of ambient noise in our graphs, right? And so we were blind to what we were about to do to ourselves when we went to 100%, right? This whole talk is about how can you learn from that first bar or the time period of that first bar instead of waiting until you go all the way to 100%, right? So one thing we want to cover before we go there, which we just saw, which was when we were looking at that Datadog graph, correlation is not causation. In this graph, we have ice cream sales and shark attacks. And it sure looks like they're related to each other, but they're actually not, right? I mean, you wouldn't think that ice cream sales lead to shark attacks or vice versa. It just so happens that there's outside factors that are driving both of those things, and it's the warmer weather. So getting back to that dashboard I showed you, the issue there wasn't our feature release. It was a customer undergoing a distributed denial of service attack. And so we, at the time, didn't have the level of sophistication in attribution, which I'm going to explain in a minute, to make sense of that and know that, oh, yep, people in the experiment and out of the experiment are having the same issues. So it's not the experiment, it's not the data, it's not the feature, sorry, we're rolling out. So this gets back to this, which is, don't believe everything you see, and can't we just change things and monitor what happens? Well, we especially can't do that when there's everything else in the world taking place, right? So there's product changes, there's marketing campaigns, there's things like the global pandemic, there could be something as simple as nice weather, right? All those things can affect our metrics. So we need some way to actually be able to observe our metrics, but actually not be fooled by something that just so happens to be going on at the same time. And science actually gives us the answer. To go beyond correlation and look for causality, science gives us an answer through the randomized controlled trial. If you're familiar with sort of the medical world, they give a placebo to half the people or some portion, and they give the drug to the others, and then they walk them through the experiment, and they try to figure out if there's a measurable difference, right? And we can do the same thing in software, and it's actually not that hard. You just need to be able to reliably distribute people through both sides without a bias. Because if you bias who goes which way, then that could bias the outcome. But if you're sending people truly random through these two things, then you can learn, right? So what happens is that you roll out a release to some portion of your users, whether it's 10, 20, 50%, and you get a lot of data points in. And then you need to do attribution, which is I need to be able to associate those data points with the experience the user is having. Which flag state does that user have, right? And you may see some patterns that emerge, right? And then you're going to really create a distribution from each of those patterns, right? And here visually you can see there's something going on here. And when I go here to this analysis phase, this is pretty clear that those distributions are not overlapping very much. They're offset. And that offset means there is probably something truly different between what these populations are experiencing, right? And so here's the thing. Most of us, I shouldn't say all of us, because I know some of you said you're shipping less than once a month, and you may be looking to get into more modern ways of tracing and all that. Most of us have some ability to tag metrics coming off our system. We've got a lot of telemetry in place, and most dashboarding tools let you tag data, and that lets you quickly ask a lot of questions and see patterns and things, right? And some of us have even better than that. We've got sort of a business intelligence database or an analytics system in-house that's consuming a ton of data and lets us observe a lot of interrelationships very quickly. And that's great. But what happens is both of those tend to be fairly ad hoc, and they tend to be not so repeatable, and they tend to be actually subject to human bias. And so what leaders have been doing for a long time, like Facebook and LinkedIn and Booking.com, Walmart, they've all created, whether they call it or not, they've created an experimentation platform, which lets them use that scientific method and the randomization and the observation to actually more quickly come up with meaningful results, right? So basically, if you take feature flags and you align data with it, okay, and that's the key. It's not just I've got some feature flags and over here I've got some data, but you want to align them, right, so that they come together. You end up with an experimentation platform, whether you call it that or not. And I just want to spend, my goal here is to kind of raise the bar for those of you who sort of have some of these pieces in place and show you how the companies that are really using this to greatest effect have paid attention to 4 key components of how you do this, right? First one is targeting. We already talked about feature flags. Most people know the feature flags let you affect who gets what, but you also want to keep track of who got what, right? So it's important that the targeting system not only be able to divvy people out one way or another, but know who got what and when they got it, okay? And then a telemetry system, this is about gathering data, whether it's data you created yourself or it's data that already exists, and pulling it in alignment with that information about the targeting, who got what and when. And then a statistical engine is where you're going to make sense of that in a rigorous, repeatable, automatic way, not based on super talented people doing a fire drill, but based on the system just kind of paying attention, looking for interesting thing you ought to know, right? And then management console. A lot of us are developers and we're like, oh, well, you know, I can do this in a database, I can do this in the command line. And you should maybe want the command line tools and all, but management console, all the mature solutions have a management console. It's for a couple of reasons. One is to democratize the thing so more people can see it and be able to use it. Another one is it increases buy-in across the organization because it's not some wizard's tool happening in a dark cubicle somewhere. It's something anybody can see, right? So let's drill in a little bit on targeting. So a targeting system, and that's the thing that decides who's going to get what. And this is essentially feature flags, right? It needs to be fast. It needs to be out of the way. It cannot delay the user experience. So it can't be something that you're hanging on a network call to do. And so everyone who's spent time building a sophisticated feature flagging system has found ways to not only decouple deploy from release, but decouple the decision from anything else so that the decision happens locally and very, very quick. Now, those two in the middle, random and sticky, this is the part that's interesting, is that we want, in order to get the benefit of not imposing our bias unintentionally, we need the distribution of people to be random, but we also need it to be sticky. And by sticky, I mean, once you put people in a bucket, we want those buckets to remain. So if I come through the system more than once, I want to have the same experience. I don't want to be randomly shuttled one way and another because I just did another session. Right? So that's what we mean by sticky. And then reliable, it really can't go down. It can't be a single point of failure. It's got to be kind of bulletproof. So you have to design this to be extremely robust. You don't want to basically have one thing that almost never breaks, but when it breaks everything, right? So you need a way that it's like, again, another decoupling, right? We want it to be super reliable. So the way sticky and random goes together, and most people say, well, how can that be? Well, actually, it's pretty straightforward. You take something you know about the user. Hopefully it's kind of a GUID or some kind of a unique key and not maybe their email address, but some unique key for the user. And you run it through a hashing algorithm. And by having a different seed for each feature or each separate thing being rolled out and controlled with a feature flag, you end up with a unique hash value for that user for that seed, right? And then you normalize that down to a number between 0 and 99. Now you've got a bucket between 0 and 99 for that user. And every time that user passes through, they're in the same bucket. Notice I didn't say they're on or they're off, or they're in the experience or they're not in the experiment, because all I'm doing now is randomly distributing them into numbered buckets. Here is where we decide who's going to get what, right? So each of these users has been given one of these numbers. And as we dial up and down the release to, from 5% to 10% or 20% or whatever, and then back down again, whether they're getting the new feature or not dictates where that line is versus the bucket they're in, right? And so it's persistent, it's deterministic, it's repeatable, right? And of course, each separate experiment is running on a different seed, so they're in different buckets for each experiment. And if we get to the QA, we'll talk about why that's important. So telemetry. So the key thing with telemetry is that you really just need to be able to gather what's happening and use the same key as you use to distribute the experience. So the same thing is determining which with the targeting needs to be recorded in telemetry. And if you're already capturing data, you pretty much just have to write a wrapper around the way you're capturing it today. And if you have your own data warehouse, you don't even have to do that because you could just extract the data from your data warehouse, right? And stats engine. So remember, we talked about how this works. We're gonna capture the events. We're gonna do attribution. We're going to create distributions. We're gonna calculate difference between the distribution, and that's where we're gonna learn very definitively. Now in stats, it's a little bit, it seems a little backwards, which is in stats, we say we're trying to disprove the null hypothesis, which means we're trying to prove that it's not true that nothing happened, or we're trying to prove that it wasn't meaningless. So the inverse, of course, is we're trying to prove something meaningful did happen, right? So when these distributions are sufficiently far enough apart, we can say with confidence that because we've isolated all the other things that might influence the outcomes, that it was the thing we changed between the two groups that made a difference. And this goes for monitoring. This goes for like, can I figure out whether something went wrong? But it also goes for, is my code having an impact? I built this feature to get people to do more of this or less of that. Is that actually happening? And I can learn that before I go out to all my users. So then the last bit, management console, right? This is, as I was saying, it's important you actually make this accessible to a wide variety of people, not just some wizard in a cube somewhere, but all the developers and all the product people and anybody else who kind of wants to know what's going on. And that will make a difference. And we'll see some examples. So here's an example from Walmart. They have a system called Expo. And if you look at the bottom right there, there's a nice, pretty UI they have, and it's very straightforward. They put a lot of energy in just making it, very clean and easy to understand. If you look top left, you can see they have a very sophisticated, high throughput data architecture that lets them move the data around really, really quick. And we'll see an example that's even more over the top than this in just a sec. On the right there, you see that their primary use of this system is they call test to learn and test to launch. And test to learn is I'm trying to figure out whether the thing that I'm doing is going to wiggle the needle. And test to launch is I think I'm going to go with this, and I want to make sure that nothing goes wrong, right? So that's more like kind of limiting the blast radius. And then we have LinkedIn. Now, if you've read Accelerate, the book, one of the key criteria that the strong performers have over the rest is that they do proactive monitoring, not just reactive, not just flying in and figure out what goes wrong when something goes wrong. And in LinkedIn's experimentation platform, that alert on the right is literally saying, hey, you know what? People who are on one side of the experience versus the other have a significant difference in site speed. So pay attention. Maybe don't roll this out to everybody yet until you figure out why that's happening, right? And then finally, here's booking.com. And booking.com has a lot of great materials on the web. They have some good videos, good blog posts. On the top left is the part that I think is the most amazing. This is their circuit breaker system. If you roll out a change and there's something so glaringly wrong with that change, that the system knows, hey, look, we're getting a lot of warnings or a lot of errors, they will literally auto revert your change and turn it back off again. Now, if you're familiar with mean time to detect and mean time to resolve, those are stats that IT groups use, right, to try to figure out how long it took to figure out something was wrong and how long it took to make it go away. Well, at booking.com, when one of these alerts fires, they can literally detect and turn off inside of a single second. So you're going to a web page, you see something that's garbled or messed up, you refresh, and it's fixed. So those of you who answered that you've been in a war room all day, which was a lot of you, imagine getting it under 5 minutes, right? So I don't think you have to get down to a second. That's kind of serious rocket science, but imagine getting under 5 minutes, right? And then some of the other stuff here, this graph on the bottom is actually their system is detecting that, you know what, the data is coming back and there's something that's wrong with your setup because this is not an alignment with what you had intended. So it's actually telling you, you probably got a bug in the way you set this up because the data is coming back funky. So if you want to go deeper, there's an awesome book that's finally out that was written by 3 very experienced experimentation people. You can get the first chapter for free at that URL, experimentguide.com. Ron Kohavi was at Amazon and at Microsoft. Diane Tang at Google, and Yazoo at LinkedIn. And they wrote a book that's not really a textbook. This is, if you're having beers with people who have been through this experience and want to share the key stuff you got to know, that's this book. Super easy to read, super well organized. It's got general stuff and it's got stuff for specialists. It's really, I can't recommend it highly enough. And then I work for a company called Split. This is the one slide you'll see about us. We are a company that was founded to productize these platforms you just saw, to take platforms that people spend years and millions of dollars on and make it a service that you can just subscribe to, right? And if you go to our blog, you can find out a lot more about things like killing a release night, using data to automate your delivery cycles, and treating every feature as an experiment, right? And I just want to offer anybody who wants a little swag, this isn't digital swag, this is real swag. So if you would like a t-shirt, just pop an email to leahhansen@split.io. I'll put that address up again in a sec. And now I want to just go to Q&A. We have a little bit of time left. So I think I've got 2 minutes till the break. So I'm going to jump over here, and while I check the Q&A, I'm going to put up some of the example blog posts to see if I can whet your appetite. And also, there's that address for getting to. Well, first question was, what's the email? And there you go. I put it up there, top right on the screen there. It's leah.hansen@split.io. And I encourage you to check out our blog. Our blog is not a sales vehicle. Our blog, you'll find the occasional article about us. Most of this is about these methodologies, what's going on in the industry, how to look at continuous integration with a different set of lenses, the impact of COVID on sort of seasonal things that are happening for people. So check out our blog. Take us up on the offer. I would love for you guys to flood Leah with requests for t-shirts. She's got it kind of all automated, so it should go pretty smoothly. And I hope that you have been able to kind of broaden your perspective on sort of what does feature flag plus data mean. And if you have a system already that you can kind of add on to that, or if you want to supplement with something commercial, obviously we're a solution, but there are others. The key is that we can make our life less stressful. We can make sure our impact is more meaningful if we just have data without drama, right? So I think that is the end of my slot. Locke, I think I've cleared all the questions too. So thank you for your time, everybody. Have a great day.